Okay, this video is just real quickly to show us how all these parent functions can be graphed and how they're related. So here we have 6 basic parent functions, and we want to know how to graph all of these here. So let's just kind of go through these. A lot of these we kind of know. We have the absolute value x. We know it starts at 0, 0, and we have a slope of 1 going this way and negative 1 this way, and it forms that V shape. Okay, so key points again are like negative 1, 1, 0, 0, 1, 1 kind of matches. X squared, we start at 0, 0 again, and we have our stepping over 1, up 1, over 1, up 3, over 1, up 5 more, and we have a curve on the right-hand side as well as the left-hand side. Okay, and key points again being 0, 0, 1, 1, 2, 4, 3, 9, perfect squares. Look at the square root, it's the inverse. We start at 0, 0, and we go through 1, 1, and it's the same numbers as x squared, but reverse. So we have 4, 2, 9, 3. We're taking the square root of inputs. So if we plug those in, we have that stepping pattern, and here's our basic curve. So there's the square root of x. The cubic root, let's do the x cubed first. So I want to have 0, 0, 1, 1, 2, 8, and so forth. And notice I'm going to do the cubic root the inverse. So I'm going to put 8 as the input, and what's the cubic root of 8? 2. So if I graph these two, notice we have a dot here, and then 8's way up here. And I'm just going to get my guiding points here. And we have this curve that goes through, has the turning point at the middle there. The inverse is the same thing, but this laying sideways. You can kind of see that curve going this way. Okay. And the last thing is, this is one we haven't really seen before, where 1 over x, well, we can do it the same way, where we say, all right, 0, 0, 1, 1. If you put 2 in, you get 1/2. Put 3 in, you get 1/3, as well as positive and negative. So what are the values that don't exist? Well, we can't have values on the y or x-axis because we can't equal 0. Can't have 0 in the denominator, and we'll never get the numerator equal 0 either. So there's our boundary lines. Now if I graph this, the key points are, 0, 0 doesn't work, so I'm going to cross that out because it's not part of the main range. But we do have 1, 1, and then negative 1, negative 1. And we have a curve that's very big, goes through 1, and as the inputs get bigger, the outputs get smaller. And we have the same on the negative side. So we have a curve that does this. Okay. So those are 6 graphs that we should know how to generate or what they look like. Now what we have here is, notice on the right we have the exact same curves, but now we have this formula. F of x equals a times x minus h, in parentheses, raised to some sort of root or exponent, plus k. In every case, our starting point is h comma k. So a couple key things are starting point, parent graph, and then scale. Okay. So notice in all these, if I want to graph a line, we have an exponent of 1. If we want to graph a parabola, we have an exponent 2. But in all the cases, we have our h and our k as our starting point. So point out a couple ones that are different. Cubic makes sense, but when we talked about roots, square root and cubic root, we're raising to a rational exponent, and we have a fraction. But it's the same setup. So we want to be able to do is look at the equation and translate it, either mentally or write it out, and what it looks like. If we have 1 over x, the x is on the bottom, notice, so how do we show that? In parentheses, raised to the negative first power. Okay. And notice we had the same thing down here for absolute value, is we had the same thing, but instead of parentheses, we have the absolute value notation. But notice the format's the same. So you can refer back to this thing to see the different items. And again, the steps are, number 1, starting point. Number 2, what type of parent graph to use. And then number 3, the scale of the graph. So those are kind of 3 steps to graph. So on this slide here, we have basically 3 different graphs. And again, what I want to show is, okay, how do we look at this graph and translate it to the equation? Well, we see what's being squared. Well, we have x being squared. Anything with it? No. So 0. So there's nothing with it. And we have 2 all by itself. So that's your k value. Now notice we don't have an a, so it's an imaginary 1. So now looking at this form, what's our starting point? 0, 2. So we put 0, 2 right here. And it's a parabola because it's x squared. So we're just going to, and we're scaling by a factor of 1, so we're just going to do our normal parent graph in the same location. So I'm just getting my guide points down, and we have ourselves a parabola that goes through there, okay? The same thing happens over here. What does the square root look like as in the graphing form? Well, we can say, okay, a factor of 1, and then what's inside the radical? We'll put it inside parentheses and raise it to the 1/2 power. So now we can look at it and say it's the exact same as the first problem. So we're going to start at a starting point of 6, -3. Notice you take the opposite of h, and we go over to 6, -3, so we're down here. And it is a square root graph, so if you want to sketch it, you know it's going to look like this. So here's our new starting point. So from here, we're going to go over 1, up 1, over 4, up 2, and our graph's going to look like that. Okay? So again, the whole purpose of this is, can you look at a function and get a very quick idea of what the graph's going to look like? And again, I'm only asking for a couple points of accuracy. Now, how do we transform this to look like the same equations? Well, what's together? The x plus 2. So let's put the x plus 2 in parentheses. The -3 is all by itself. We have no factor in front, so put the 1. So what exponent do I put? Well, since it's in the denominator, put it to the -1st power. So now it tells us what parent graph to use. Our starting point's at -2, -3. And we're going to start at -2, -3, so put in my starting point. And again, we have asymptotes, so I'm not going to put dashed lines, well, I probably should. Hopefully you can see them there. I'll put them in green. So these are the areas where we cannot have values. And again, our graph has a scale factor of 1, so I'm just going to be 1 box away. And we're just going to go along our asymptotes and sketch in our graph what it looks like, okay? So notice, I was very quickly able to get 3 different graphs going, and they all were in the same format of different degrees, but starting point, and then parent graph, and then the scale of the factor. We don't have a whole lot of scale in these examples, but we'll see that a little bit further in the chapter. But I just want to kind of get you started with graphing, so this is kind of a little extra video on how to do that.